Hello everyone and welcome to our live coverage of EUMETSAT MTG-S1 mission launching from the Space Coast, that is from Launch Complex 39A at NASA's Kennedy Space Center in Florida. We hope you all are doing fine and excited about the upcoming SpaceX Falcon 9 launch that will push its limits today. We will talk about that, what makes this mission an exceptional one, in a while. Now, if it's your first time joining us, hi, my name is Dipto Maitra. I'll be your friend and the host providing commentary for today's mission launch, and you are watching AstroYonder live.
Roger, 0G, and I feel fine. Capsule is turning around.
Houston, we see a nominal MECO. Welcome to space.
We are super excited bringing you the coverage of SpaceX's 510th overall launch and the 82nd Falcon 9 launch of this year. This launch marks the 497th Falcon 9's overall launch. Today's launch is the 54th one from the Space Coast as SpaceX is on its way building their record-breaking launch cadence for this year. We are currently standing by for a Falcon 9 liftoff at 5:04 p.m. Eastern Time, 21:04 hours UTC from Florida for a southeasterly launch for EUMETSAT MTG-S1 satellite, sharing a ride as a part of the Copernicus Sentinel-4 mission. Now, before we dive in to the mission details, on behalf of AstroYonder team and our awesome moderators, thank you all for joining us for today's launch. We are so grateful to have you as part of the stream. Really appreciate you being here. A huge shout out to our amazing YouTube community for the support as we bring you detailed coverage of space launches with all the stats and in-depth insights. We are truly grateful to have you all here with us. We would love it if you guys join the chat and let us know where you are joining from. Also, feel free to share any questions, suggestions, or opinion with us. We would love to hear from you guys. Now, just a reminder, it's me only managing the launch coverages on my own. So if by chance we face any technical hiccups or issues, although the chances are less, but please kindly bear with me and hang tight. I will do my best to guide you through the upcoming Falcon 9 rocket launch happening in approximately 57 minutes from now. SpaceX will be starting their webcast 15 minutes prior to the liftoff. So here we are a little earlier starting our stream to share the insights with you guys. Now also would like to welcome Cosmonauta for joining us and finding our live stream using ChatGPT. I guess ChatGPT is making some sense nowadays, prescribing our live streams. But thanks Cosmonauta for joining us, and I hope you are doing well. And I guess you will be enjoying the stream as well. Now let's get into the mission details. According to the 45th Weather Squadron officials, today it's not a fair weather conditions for the launch. According to the 45th Weather Squadron officials, there's a 20% chances of favorable weather conditions at the time of the launch, with massive 80% probability of launch weather constraint violations related to cumulus cloud, surface electric fields, and anvil cloud rules. Although today it's a 150-minute launch window we have, and despite such bad weather conditions, the good thing is that SpaceX may have some brief periods where weather conditions are favorable. Otherwise, it's a 20% go for today's launch. For backup opportunity, tomorrow at the same time, the weather still isn't promising with 90% probability of launch weather constraint violation. That means only 10% go, even less than from today. The forecast calls for a temperature of 29 degrees Celsius, clear skies right now with 10% cloud cover and a wind speed of 15 miles per hour. So let's keep our fingers crossed and hope the launch proceeds on time without significant delays. Well, one thing, did you notice we are just 4 more launches to reach 500 successful missions supported by the Falcon 9 itself. Just last month, SpaceX hit a huge milestone with the June 12th Starlink launch from Vandenberg, marking their 500th successful mission. And again, another milestone for them waiting around the corner. Now let's take a look at today's payload details. We are about 53 minutes away from liftoff as I speak, and this is a massive deal for weather forecasting across Europe and Africa. I'm going to unpack all the details about the MTG-S1 satellite in a way that's technical yet approachable. It may take a little while, but I hope you will be having the patience to know and hear me out. Now, today's mission is being operated by European Organization for the Exploitation of Meteorological Satellites, also known as EUMETSAT in short. Today's payload is a part of EUMETSAT's Meteosat Third Generation program, and it's loaded with some seriously impressive gear to help us decode the mysteries of our atmosphere. MTG-S1 is the first of two MTG-S. The S stands here for the sounder. So it is the first of two MTG-S satellites complementing the MTG-I series, and here the I stands for Imager, with a total of 6 satellites planned under the MTG program. Today it's the second flight unit of MTG satellites and first of the S type. As I mentioned before, S stands for the sounder. Now let's start with the basics. This satellite is no lightweight. It tips the scales at around 3,800 kilograms, which is roughly the weight of a small elephant, you can say, or a couple of mid-size cars. It's being crafted by talented crew at Thales Alenia Space in Europe, serving as a prime contractor with some key support from OHB Systems for MTG-S and Kaiser Thread handling the IRS instrument development. This satellite is built to park itself in a geostationary orbit, hovering about 35,786 kilometers above the Earth. I say geostationary orbit, as I said, it's a typical height of the altitude of the geostationary satellites to be parked at, and it will be there where it can stay locked in a place relative to the ground. That's a sweet spot for keeping a constant watch over Europe and Africa, and it will settle in at 0 degree longitude. You can say it's having 0 degree of inclination also, right over the equator, giving it the perfect vantage point. This high orbit means it won't zip across the sky like some other satellites. Instead, it will just sit there staring down at the same patch of the Earth 24 into 7. Now let's get into the heart of the mission, that is the payload, which is the fancy tech doing all the heavy lifting. The star attraction in the infrared sounder is the infrared sounder, or the IRS. And trust me, this isn't uh, a typical snapshot camera. It's a hyperspectral wizard that can slice through the atmosphere layer by layer, measuring temperature, humidity, and even trace gases like carbon dioxide or ozone at different altitude. Picture it like a 3D weather X-ray machine. It takes about 60 minutes to scan the entire Earth disk with a resolution of 4 kilometers, which is sharp enough to catch the subtle. Just a second. Uh, I should be pausing this after this slide will be playing. So what I was saying that it is like a 3D weather X-ray machine. It takes about 60 minutes to scan the entire Earth disk with a resolution of 4 kilometers, which is sharp enough to catch the subtle hints of an approaching storm or a brewing hurricane. Now for Europe, it can zoom in on the local areas in just 30 minutes, giving forecasters a quick heads up when things get dicey. To pull this off, the IRS relies on two cryocoolers to keep its detectors ice cooled at 55 Kelvin. That's about minus 218 degrees Celsius, which is crucial for keeping the data crystal clear. This is a first for Europe in geostationary orbit, so it's a big leap forward in predicting several weather like thunderstorms, floods, and even heat waves. But we have more. Alongside the IRS, we got the ultraviolet visible near infrared, also known as UVN sounder, which is hitching a ride as part of the Copernicus Sentinel-4 mission. This one's all about atmospheric chemistry, acting like a detective for air quality. It analyzes light in ultraviolet, visible, and near infrared ranges to track pollutants, ozone levels, and tiny particles that affect our health and climate. Whether it's smog over a city or a shift in the ozone's layer, this tool will give scientists a detailed snapshot of what's floating around up there. Together, these instruments churn out. Please excuse me. Together, these instruments churn out data at a whopping 260 megabytes per second, with the IRS kicking in 167 megabytes per second on its own. That's a ton of information streaming back to Earth for real-time analysis. Powering this high-tech setup is a solar array spanning 10.7 square meters, which pumps out around 2 kilowatts of electricity, or you can say power, enough to run a small house or keep the satellite humming along for its planned 8.5 years mission, with some extra fuel in the tank to stretch to 10.7 years if all goes well. Now, when fully extended, this array stretches out about 30 meters, like a pair of giant wings. To keep its spot steady, MTG-S1 uses an electric propulsion system, which is like a gentle, precise push to adjust its position and counter any drift. It's not a flashy as a rocket blast. Excuse me, what is happening with my throat? I don't. Please excuse me. My throat is so like I can't talk so much clearly. What I was saying that it's not as flashy as a rocket blast, but it's perfect for a long haul in a geostationary orbit. The satellite runs on a small geo Luxor bus, a reliable platform adapted by OHB system. The IRS itself is a beast with a detection chain that includes two 160 by 160 pixel arrays, each cooled to 55 Kelvin, which I mentioned earlier, and a 16-bit video chain that processes data at 2 gigabytes per second. It can handle spectral ranges from 680 to 2250 centimeter inverse centimeters, covering mid-wave and long-wave infrared with a spectral resolution of 0.6 inverse centimeters. That's technical stuff, I know, but just wanted to give you a clear picture. Also, with this precision instrument, the satellite will be also taking some super precise measurement. Now think of it like tuning into radio station, being able to pick up stations that are very close together on a dial, allowing for more precise atmospheric listening. It helps detect very subtle differences in atmospheric absorption features, making it excellent for profiling gases like water vapor, carbon dioxide, or ozone. The UVN-Sounder adds another layer with its own set of detectors tuned to catch those critical atmospheric signals. So, the big goal here is about keeping us safe and prepared. This satellite will give weather forecasters and scientists a front row seat of the atmosphere, creating 3D maps that shows what's happening at different heights and tracking air quality changes. That means earlier warnings for severe weather and some more lives to be get saved. In a nutshell, this satellite is a weather and air quality superhero built for a precise weather forecasting with top-notch tech to help us stay one step ahead of Mother Nature. Although I guess today Mother Nature will be uh, in favor of us as the weather conditions out there at the East Coast are not favorable, and today we are having only 20% go for the launch. Now, once again, just a reminder, SpaceX is currently targeting a liftoff time of Falcon 9 from NASA's Kennedy Space Center in Florida at 5:04 p.m. Eastern Time, 21:04 hours UTC on Tuesday, July 1st of 2025. Now just let me check if the liftoff time is still the same or not. As of now, it seems they are sticking with their liftoff time without any alteration. Just they altered the webcast 2 minutes earlier, which I knew they mistakenly placed that webcast. Now let's take a look at the flight record for the booster supporting today's mission. The booster with tail number 1085 will be supporting today's mission. This supporting booster had previous 8 flights in its record, including missions like Crew 9 that marked the 9th operational NASA Commercial Crew Program flight and the 15th crewed orbital flight for Crew Dragon spacecraft. also bringing back home the Starliner crew flight test astronauts Sonny Williams and Butch Wilmore after their extended stay aboard the International Space Station. Next supported mission was the GPS Block 3 RRT-1 mission, Firefly Blue Ghost Mission 1 for Firefly Aerospace's lunar lander that was quite successful and provided us breathtaking visuals from the moon. Next up is the FRAM 2 mission, which marked the first ever crewed mission launched into polar orbit. And the last non Starlink mission supported by this booster was SXM-10 for Sirius XM. And additionally, this booster supported 3 Starlink missions. The booster's turnaround time as of today is 25 days, now awaiting its 9th flight, just 39 minutes away from now. The last mission supported by today's booster was the SXM-10 mission from Space Launch Complex 40 on 7th of June this year, that is 2025. Today is the 5th flight of this booster with previous 3 supported non-Starlink missions and 1 Starlink mission for this year. This will be the 3rd time the booster getting launched from Launch Complex 39A and having its 4th landing on Just Read the Instructions drone ship. Now let's have a look at the bar graph showing the number of Falcon 9 launches each year. Before this upcoming launch, SpaceX completed its 81st Falcon 9 launch for this year with the Starlink Group 15-7 mission from Vandenberg on June 28, 2025, obscuring the number of annual launches made till year 2022. Right now, SpaceX is having 20 more than the launches made in the year 2022. With today's launch of the EUMETSAT MTG-S1 mission, the bar graph shows 82 number of Falcon 9 launches for 2025. As of now, SpaceX is less than halfway to reach the number of launches made in year 2023 and 2024. And with today's launch, SpaceX will be having 14 behind 2023's total and 50 short of 2024. We know last year SpaceX pulled off 132 Falcon 9 launches, marking a year with highest annual launches with a total of 134 launches, including 2 Falcon Heavy flights. Once again, SpaceX is now aiming for another record-breaking year with around 170 to 180 launches, surpassing last year's highest annual launch count. Although it's pretty ambitious target, but hopefully it gets achieved. Now, having your support inspires us to push forward and give our best to meet what you hope for. If this stream fuels your love for space, give this stream a like. It's kind of fine-tuning the trajectory of our mission to build a community with amazing space enthusiasts like you. And don't forget to subscribe and turn on the notification so that you won't miss a single launch update like a perfectly timed window. Here at AstroYonder, we believe together we will build the ultimate space constellation of space enthusiasts. Really would be super grateful to have you with us in our future stream. Now, once again, please allow me a couple of seconds to check whether the launch is on time or not and to stay updated. Yes, it's still on time. I have to keep checking this launch time today because weather is not favorable, as I mentioned. Now, skipping the pre-launch timeline, since it's a typical Falcon 9 launch for every other mission with absolutely no alteration and or deviations. You can track the pre-launch timeline updating live on the upper left side of your screen However, there's one point I would like to mention just for your quick knowledge, and which you might be knowing, that the strong back reclining process at the Cape Canaveral and Kennedy Space Center differs from that at Vandenberg. Here at Cape Canaveral and Kennedy Space Center, we recline the strong back about 1.5 degrees or 2, whereas at Vandenberg, we recline the strong back about 13 degrees away from the Falcon 9. That's the only thing which is different in today's pre-launch schedule, as this is a East Coast flight. Once again, just to remind you, SpaceX is currently targeting a liftoff time of Falcon 9 from NASA's Kennedy Space Center in Florida at 5:04 p.m. Eastern Time, 21:04 hours UTC on Tuesday, July 1st of 2025. Now let's go ahead and have a look at the trajectory for today's mission. Falcon 9 leaving the pad from Launch Complex 39A at Kennedy Space Center with the MTG-S1 satellite on board for a somewhat southeast trajectory heading into geosynchronous transfer orbit, indicated by that green line on your screen. The red line indicates where Falcon 9 first stage will land after stage separation, just a little later, leaving Florida's Space Coast. Today's mission is supported by Just Read the Instructions drone ship, one of the two here at the East Coast. This will be the 125th landing on Just Read the Instructions drone ship to date. Now here are some of the stats related to drone ship as of today on your screen right now. We are 15 minutes away from the webcast to begin. Now currently we know there are 3 in SpaceX's drone ship fleet, but we expect an addition of a 4th drone ship as promised by SpaceX earlier, possibly occurring late this year or who knows, early next year, because as of now we are not getting any information regarding that. We know of the 3 drone ships, Just Read the Instructions and a shortfall of Gravitas are based here in Florida, while of course I Still Love You is stationed in California. Now speaking of fairing recovery, SpaceX will utilize a recovery vessel to retrieve both the fairing halves from the Atlantic waters. The 2 halves of the payload fairing will be recovered slightly farther downrange from where the first stage lands on Just Read the Instructions drone ship, after they will smoothly splash down with the guidance of parachutes. We know SpaceX manufactures the fairings in-house, with the total cost for 2 halves is nearly $6 million. So of course it's no wonder that SpaceX aims to recover the fairing for repetitive use, following its same approach with rocket boosters, upholding the motto of reusability and sustainability. Now right now you can see on a screen how a fairing recovery operation looks like. The recovery vessel on your screen is Doug performing the recovery operations, but today's supporting recovery vessel is Bob here at the East Coast. Other recovery vessels, Doug is gearing up for the upcoming starting mission from Cape. That will be also a record setting mission, as on that flight again the booster with tail number 1067 will be marking its 29th flight. That's the first time a Falcon 9 booster flying for its 29th time. Now, while Go Cosmos here at the East Coast and Go Beyond at the West Coast are awaiting their next assignment. Now, I guess you heard Megan, the Dragon recovery vessel, was retired in the third week of June 2025 after completing her final mission with Crew 9 in March. She recovered a total of 24 astronauts in her career, so we should be bidding a warm hearted farewell. Godspeed, Megan. Now, before proceeding, once again, let's just check whether the launch is proceeding as scheduled and keep ourselves informed. Yes, as of now, everything seems to be perfectly tuned in as SpaceX is sticking well with their lift off time. No delays. I think the weather is cooperating with us. Now we have a request again for you folks. Consider giving this stream a like as your way boosting us past max Q, passing through the maximum dynamic stress of YouTube algorithm. It really helps us to connect with more space enthusiasts like you and growing our community. As we are burning our all day and right now it's midnight 2:05 a.m. here. So it's kind of all day propellant we are expanding to bring you the streams packed with stats and insight. We expect your kind support for us by typing the subscribe and the bell icon. And with that, you will never miss an upcoming stream like a perfectly timed launch window. Your support would really inspire us and keep up with our hard work to meet your expectations. Now we are getting close to the webcast. We are just 9 minutes away. So let's just quickly get done with the stats we have for you to share with. Today's launch marks the 510th SpaceX's overall launch and the 22nd dedicated non-Starlink launch of this year. Just the previous one was the Axiom 4 mission. Now this is going to be the 497th Falcon 9 launch to date. Ninth flight of this particular Falcon 9 booster supporting today's mission with tail number 1085 making a move after 25 days. By that I mean the booster's turnaround time is 25 days. Today's mission marks 82nd Falcon 9 launch and SpaceX's 85th overall launch of 2025. This will be the 438th Falcon booster reflight to date. That is the launch of a booster that has flown at least once before. 114th orbital launch for SpaceX, launching from Launch Complex 39A, and the 208th overall orbital launch from this pad. Now moving on to some reusability statistics. This launch marks 422nd Falcon 9 booster reflight to date. This will be the 125th landing on Just Read the Instructions drone ship. 9th landing of this first stage booster with tail number 1085 supporting today's mission. With this mission first stage landing, SpaceX will be having their 380th overall drone ship landing, marking 451st Falcon 9 landing so far and 470th SpaceX's overall landing to date. Now, just a note, we are not counting the landing failure on the Just Read the Instructions drone ship during the Starlink Group 12-20 mission this year as a partial success. So there's a difference of 1 in Falcon 9 and overall landing stats compared to what it is listed on SpaceX's website. So I just made it clear so that you won't be getting confused by the numbers there on your screen right now. Now, speaking of landing, let's look into some stats for drone ship landings prior to today's mission. Please note that these drone ship landing stats on your screen right now are excluding today's mission. These are prior to today's launch. Now let's have a look into some key stats for SpaceX launches for this year specifically, including today's mission. With today's mission, SpaceX will be having its 85th launch of this year, and out of those, 60 were Starlink missions, 22 are non-Starlink missions for commercial and government organizations, including this one, and 3 Starship launches. 78 of these missions using a reuse booster, including today's one. Now, if we look into the geographical distribution, we get SpaceX will be having 54 launches from East Coast, 16 of them from Launch Complex 39A with today's mission. On the West Coast, having 28 launches, that is from Space Launch Complex 4 East at Vandenberg Space Force Base. And as of now, 3 launches from Gulf Coast at Starbase in Texas, and 2 Super Heavy booster catches with Starship 7 and 8 test flights. On Flight 9, no Super Heavy booster catch was attempted, and we just crossed the previous launch, like speculated launch date for the Starship Flight 10 on June 30th. I hope they will be recovering the test site sooner so that we can have the 10th flight. Now for landings, SpaceX will be nailing it for the 80th time this year. Most of the landings are on drone ship with 70 landings so far with today's mission. Just Read the Instruction will be having its 22nd landing for this year. For ground landings, they pulled off 10 of them. And right now, SpaceX is working on adding a landing pad at the East Coast in order to retain their return to launch site, also known as RTLS capability, as SpaceX's lease for landing zone 1 and 2 expires in July. Prior to today's launch, the success rate for ground landing is 98.90. For drone ship landing, it is 96.93%, and the overall landing success rate is 97.30%. The landing success rate for this year dropped to 98.75% due to the failure of the booster with tail number 1086 to land on Just Read the Instructions drone ship during Starlink Group 12-20 mission. And for that reason, we are not counting one landing stats for the Falcon 9 and the overall landing for SpaceX's. Today's mission is the 146th launch since last mission failure, that is the Starlink 9-3 mission. Now we are just 2 minutes away from the webcast to start. So we are also having getting close with our stats as well. Once again, this page of stats are prior to today's launch. What we have is 145 successful launches since last mission failure, 55 successful landings since last landing failure with Starlink 12-20, booster with tail number 1067 having highest number of flights and successful landings, that is 28 times as of today, with previous Starlink mission launch of group 6-83. With the next upcoming Starlink launch, that's going to be 29th launch of a Falcon 9 booster, and another record-setting milestone for SpaceX. 356 mission with at least one reuse fairing and approximately 680 number of fairing halves were reused prior to today's launch, with a fairing half reused to reach 32 times. Now moving on to this year's orbital launches, we have this pie chart including this one. Today it's 146th orbital launch of the year. Also it's 146th successful mission for SpaceX since last mission failure. United States is leading with 97 launches, followed by China with 35 launches, Russia with 7 launches, 2 launches each by Japan and India, and Europe with 3 launches. Australia is about to debut with the launch of Eris rocket scheduled no earlier than July 3rd, which previously got scrubbed on its initial attempt due to some fairing half issues. Now we have this pie chart showing 2025 orbital launches by rocket variations, including today's launch, Falcon 9 gearing up for its 82nd flight. Now while you guys check out the pie chart, let me see if the stream is rolling or not, as it's about the time for the webcast to begin. I guess, yep, it's live. That's quite on time. So let's head over to the webcast. Please give me a moment to set things up. Right now, SpaceX is playing some pre-launch tune, so you are not missing anything. As I mentioned, SpaceX is having some pre-launch tunes going on. I will pass the mission audio feed once it drops. And also would like to remind you guys, if there will be any copyrighted tracks playing on the stream today, we won't be able to play those clips when they will be streaming, as they are having copyrighted tracks. Otherwise you will have a clean feed. Adding value to your viewing experience is our top priority here at AstroYonder. If you felt we somewhat achieved that, please consider liking this stream. It really helps others to find this stream. Also consider subscribing to our channel, as we work hard to bring you streams packed with stats, details, and insight. We would be incredibly grateful for your support. Now in today's post-launch timeline, we will be having some deviations, and I will be saying them in details when we will be going through each of the milestones after the liftoff. Also during the post phase, I will be discussing that what makes today's launch a special one. It's a little bit of a technical thing and an insider aspect. So I hope you will be enjoying hearing to those milestones achieved by today's mission. Once again, it's not an ordinary launch today we are having. Previously, we did had geo transfer orbit satellite launched, but today it's a little bit different. But I will be describing them in details during the second phase. Second stage will be in the coast phase. Right now, I don't want to bother you with technicalities. That time we will have enough time to discuss things. We have the stream online. As soon as the mission audio feed comes in, I will patch it for you guys. Also would like to welcome Lunar Titan for joining us. Thanks for tuning up, Lunar Titan, and I hope you'll be enjoying the stream.
A live view of SpaceX's Falcon 9 rocket as we prepare to launch the Meteosat Third Generation Sounder 1 mission from Launch Complex 39A at Kennedy Space Center in Florida in just under 14 minutes from now. My name is Shreya Chintalapudi, and I'm a supply chain reliability engineer here at SpaceX.
And I'm Zachary Lupin, an avionics supply chain engineer, and we are joining you live from SpaceX in Hawthorne, California.
As of now, we are getting this live view of Falcon 9 from Launch Complex 39A. It seems that the weather is, as of now, is quite cooperative, despite having bad weather forecast from the 45th Weather Squadron.
Operational sounding satellite in geostationary orbit.
Now, MTG-S1 is carrying 2 missions this evening, the Infrared Sounder and the Copernicus Sentinel-4 Ultraviolet Visible Near-Infrared Light Imaging Spectrometer. And in combination with Meteosat 12, which is already in orbit, MTG-S1 will enable weather and climate scientists to get a 4D vision of the dynamics and composition of the atmosphere.
At just about T-minus 13 minutes, everything is looking good for an on-time liftoff of 5:04 p.m. Eastern Time, and the range is ready to support. Weather is currently green for launch with no concerns here at the top of the window. If for any reason we are unable to launch today, a backup opportunity is available tomorrow at the same time. That's 5:04 p.m. Eastern Time. And with that, let's take a look to learn a little bit more about the Falcon 9 supporting today's mission.
Well, now they will be describing about the Falcon 9. It's not such important. We are quite accustomed about the Falcon 9. But that's the good news. We just heard from the host there at the SpaceX that they are having no issues with the weather at the top of the launch window today. And once again, just to remind you, we do have a backup opportunity as we just heard, but tomorrow it's only 10% go according to the 45th Weather Squadron. And today, as we are getting some brief periods where we are getting some favorable weather conditions, I guess tomorrow we won't be getting that. So let's keep our fingers crossed and hope the launch proceeds on time today. And also, I'm a little bit skeptical about the Falcon 9 launch for the Starlink mission tomorrow, as it's the same East Coast having such bad weather forecasted by 45th Weather Squadron. We got some visuals of just read the instructions drone ship some couple of minutes ago. We did got the call out for the spacecraft being on internal power right now. We are getting T-minus 11 minutes from liftoff. As of now, everything seems to be perfect. Absolutely no issues with the weather, confirmed from SpaceX's end as well.
Of the payload being encapsulated in the fairing a few days ago. About 3 minutes into flight, both halves of the fairing will separate and parachute back to Earth. Both fairing halves on today's mission are flying for their first time today. If recovery goes to plan, the fairings will be pulled from the ocean and prepped to fly again on future launches.
Now, so much of what makes Falcon 9 remarkable happens in flight. We have stages separating, the first stage landing itself on a drone ship in the middle of the ocean, fairings parachuting back to Earth, all ready for another flight to space. Every part of Falcon 9 is part of a larger design that comes together to do one thing, and that's to escape gravity. And that is the first step in building our multiplanetary future.
And that's a future I'm definitely excited to be a part of. While the countdown continues, here is a video from our customer for today's mission, EUMETSAT.
So guys, I can play this audio over here. You can enjoy the views, but we can play the audio here because these are having the copyrighted tracks, and that can cause us to have copyright strikes. But one thing we got to know that today both the fairing halves are flying for the first time. So new fairing halves as well. SpaceX are like overwhelming us with so many things to happen at the same time, and with their like records to have to, they are making my head crazy at least. Now, in today's post flight, I thought they will be saying, but they didn't say it. Today's one will be a little different. We will be having the first stage landing at approximately T plus 7 minutes and 59 seconds. But generally, in other Falcon 9 missions, we do have the SECO after the stage after the first stage landing, but today we will be having the SECO 1 prior to the landing. And please excuse me, I mentioned the time wrong. The landing will be happening at T plus 8 minutes and 28 seconds, and we will be having the SECO 1 at T plus 8 minutes and 1 second. So it's just a similar we did had in the just previous Axiom 4 mission. And also we do have some other things to discuss, that what makes today's mission a little different from other launches which we had in previous for geostationary orbit deployment. And I will be discussing them when the vehicle will be in the coast phase. The second stage will be in coast phase. Today, after SECO 1 at T plus 8 minutes and 1 second, which will be happening prior to the first stage landing, the second stage will be in about 90 minutes of coast phase, as vehicle will be ascending to its target orbit for payload deployment. Now again, at T plus 26 minutes and 54 seconds, second stage MVAC engine will ignite for the second time in today's flight, and that burn will be around 1 minute and 6 seconds, and the second stage will shut down again at T plus 28 minutes. Just after that, it will be the SECO 2, and following that we will be again having about 7 minutes of coast phase, and at T plus 35 minutes and 11 seconds the payload will be deployed. So we have to hang today for 35 minutes. Right now stage 1 RP1 load is complete. We are still loading the RP1 in the second stage, and also we are still loading the LOX, that is a liquid oxygen, on both the stages. We will be listening in a couple of minutes for the LOX load completion for both the stages. Right now we are getting T minus 5 minutes and 37 seconds approximately from the liftoff. A couple of important steps were completed. The spacecraft team switched to internal power, as I mentioned previously a few minutes ago, and fueling of the Falcon 9 first stage is finished, meaning all the RP1 propellant is now on board. We are still loading the liquid oxygen on both the first and second stage. Also, we are currently chilling in the Merlin engines backup from T minus 7 minutes when we open up the pre-valves, which allows the propellant down to the engines to get them prepared for the ignition just before T0. We are right now pressurizing the tanks for the strong back retract. Right now we are adding a bit of gas to stiffen up the tanks so the clamp pumps can open up with a solid structure holding the Falcon 9.
There's that call out there. As they open, the rocket is fully free at the top.
Upon opening those clamp pumps, we will be reclining the strong back about 1.5 degrees or 2 from the Falcon 9 since it's a East Coast flight. Soon we will be getting those visuals as we are now having the close-up view. And there we go. You can see those clamp pumps to open up, and as the degree of reclination from the Falcon 9 is a low value, so you have to be a little bit providing attention. It will be reclining a little bit far from the Falcon 9. That's I mentioned 1.5 degrees away from the Falcon 9. So unlike Vandenberg flight that reclines 13 degrees away from the Falcon 9, where we can see the reclining of the Falcon 9 with a substantial degree, this won't be such far going. Now we are getting close to T minus 3 minutes. Right now we have the stage 1 LOX load complete. We are still loading the liquid oxygen on the second stage, and that will finish up at just inside T minus 2 minutes mark. Right now everything continues to be smooth. The range is green, and the weather, of course, as we can see, has cooperated. We don't expect any weather conditions to develop in last couple of minutes. We will be listening in couple of seconds for the LOX load close out for the second stage.
Few minutes here of terminal count.
Coming up shortly, we should hear
Stage
that.
2 LOX load complete.
And
there we go. Stage 2 LOX load is complete. All the propellant are now on board with massive 1 million pounds of propellant. We are now beginning to vent down the pressure that was on the tubing on the strong back. That's why you can see those clouds coming out there, and it's absolutely healthy. Rather, it's a positive indicator of launch coming up. Next event, T minus 1 minute, we should hear the call out that the Falcon 9 flight computers are in startup and controlling the rocket for the remainder of the countdown. We are getting some spectacular views out there from the East Coast. Falcon 9 at Launch Complex 39A.
Falcon 9 is started.
Right on time. Falcon 9 flight computers are on both the stages, are running through the rocket through last minute of count. Now let's listen to the go call out.
Launch director, go for launch.
And there we go, SpaceX launch director giving go for the launch. We are getting close to T minus 30 seconds. All systems continue to remain go for the launch of Falcon 9 and the MTG-S1 satellite. So now let's sit back and enjoy the liftoff.
T minus 15. T minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition and liftoff. Go Falcon, go MTG-S1.
Vehicles pitching downrange.
And take motion to cover.
Amazing views. I hope you guys enjoyed that row, and we are right now getting some awesome tracking views of the Falcon 9. We are T plus 30 seconds into the flight. Falcon 9 on its way with the MTG-S1 satellites into geostationary transfer orbit. Right now, we are into a throttle bucket, throttling down the 9 Merlin engines, preparing for the period of maximum dynamic stress coming up. We got some good call out, power and telemetry is nominal. And right now, Falcon 9 is supersonic. It means that we have exceeded Mach 1 on the Falcon 9. Falcon 9 is faster than the speed of sound as we have gone supersonic. Next up, we will have the max Q call out.
Max Q.
And there we go. We are through the period of maximum stress on the vehicle. We have throttled the 9 Merlin engines back up to full power. Next up, we will be hearing the call out for MVAC engine chill.
Horizontally in order to avoid being pulled back down to Earth and get into orbit. You can keep an eye on the stage 1 telemetry on the bottom of your screen.
Now we're going to have several
Back in flight chill.
good.
And there we got the call out MVAC engine chill. We are now starting to chill down the MVAC engine on the second stage in preparation for ignition right after stage separation. Up next, we will see 3 events in rapid succession. First, main engine cutoff, also referred as MECO on the first stage, followed by second stage separation, and then the first ignition of the second stage's MVAC engine, also known as SES1, which will boost the payload to the orbit. So let's listen in for those callouts.
Just waiting on
MECO.
that. There's that MECO call out they were looking
Stage
for.
separation confirmed. MVAC ignition.
So there we go. We got all the callouts for all back-to-back milestone. Now, if we will be getting those first stage onboard view, we will be able to see that those 4 hypersonic titanium grid fins to begin deploying, and right now you can see as we have a successful stage separation. Next up, we'll be waiting for the fairing separation confirmation. Absolutely amazing views from both the stages. Even today, the Falcon 9's first stage view is also crystal clear. And we have the first view of the payload.
Separation confirmed.
Amazing view there.
We got out the call out that the fairing has successfully separated. Today, both the fairing halves were flown for the first time. Right now, we are getting some cool views from the second stage and from both the stages, I should say. Now the first stage will continue to rise towards apogee before descending back towards the landing on drone ship. Just read the instructions. Station in the Atlantic Ocean. Second stage, meanwhile, with its full capacity in middle of its less than 6 minutes of burn today. Other days we are having about 6 minutes of burn, but today it's less than 6 minutes of burn. Is on its way into the parking orbit with MTG-S1 satellite payload on board. And right now, I guess the apogee for the first stage is 120 kilometers of altitude before descending back towards the landing on drone ship. Just read the instructions. Now, a little bit about the upcoming launch for Gilmore Space for Australia is now preparing for their inaugural flight of the Iris Block 1 rocket targeting July 3rd from Bowen Orbital Spaceport launch site in North Queensland. It is the first Australian-made rocket aiming for orbit from Australian soil. Also, SpaceX will set yet another record tomorrow. For the first time, a Falcon 9 booster will embark on its 29th flight. And I hope and pray as well that tomorrow also the weather will be cooperating as of today, as tomorrow's flight is from Cape. It's the same space coast from where today's launch happened. Now, currently, we are preparing for the first stage to make its return to the drone ship landing site. For the site, we just read the instruction. Next up, we will be hearing the call out for stage 1 entry burn startup. During this part of the flight, stage 1 relies solely on its grid fins for steering as it returns to Earth. And you can see those nitrogen gas bursts from the first stage for attitude control. Also,
entry burn startup.
and there we go. We got two callouts back to back. Stage 1 entry burn startup and stage 1 FTS being saved. We just lit 3 of 9 Merlin 1D engines on the first stage, rapidly slowing down the vehicle. You can see from the bottom left hand side of your screen from the telemetry. And this burn lasts just around 23 seconds, and we got the call out for stage 1 entry burn shutdown. Now Falcon 9 is equipped with 4 landing legs, and those landing legs are made out of carbon fiber with aluminum honeycomb. This will be deployed just prior to the landing. Next up, if we will be hearing the stage 2 FTS being saved, it means the orbital insertion burn is complete.
190,000 pounds of thrust each during ascent.
Next up, we are expecting also to get a call out for stage 1 being transonic.
47 airplanes at full power. And the MVAC engine on the second stage, which has a much wider...
And the next major milestone in today's flight is right now stage 1 landing burn we are waiting for.
Over 30 seconds, the second stage Merlin vacuum engine will shut down.
Stage 1 entry transonic.
There we go, we got the call out, stage 1 being transonic. It means that the stage 1 is traveling slower than the speed of sound. We are less than 60 seconds away. Wow, awesome views. You guys just noticed those drag around the grid fence, and we did got the call out for stage 1 if the stage 2 FTS being saved. It means the orbital insertion burn for the second stage is complete. And there we go, landing burn. Great views of the landing burn with center A9 engine now lit. With that, we are slowing down the vehicle furthermore very rapidly. Should be seeing those landing legs deploy any seconds now.
Stage 1 landing leg deploy. Stage 1 landing confirmed.
And there's that.
And we got the call out for successful landing of the Falcon 9. This marks the 451st landing of an orbital class Falcon 9 rocket. Now we did got the call out earlier for the SECO 1, that is the second stage MVAC engine cutoff. It is right now in the second stage is in coast phase. Unlike other Falcon 9 launch where we do have the SECO 1 following the landing of the first stage. Today it happened prior to the landing. Now the second stage will be in about 19 minutes of course phase as the vehicle ascends to its target orbit for the payload deployment. Next up, at T plus 26 minutes and 54 seconds, second stage MVAC engine will reignite for the second time in today's flight for 1 minute and 6 seconds of burn, and will again shut down at T plus 28 minutes. That will mark the SECO 2. Following that, second stage will, with the payload on board, will be again in a course period of about 7 minutes, and at about T plus for 35 minutes and 11 seconds the payload will be deployed. Now as we are in the course phase for a period of about 90 minutes, so let's discuss that why this mission is a little bit of different from other Falcon 9 launches for a targeting a geostationary orbit to place its payload. The satellite itself weighs around 3,800 kilograms, as I discussed during the payload details to discuss, which is pretty light compared to what SpaceX's Falcon 9 can handle. More on that, it can handle Falcon 9. Now, the plan is to launch it into a geosynchronous transfer orbit, which is likely a stretched out X-shaped orbit with a low point, or you can say the perigee, close to Earth, around 185 to 250 kilometers, and with a high point or the apogee way out in space. Now from there, the satellite will use its own engines to climb into that final geostationary spot. As I mentioned about those electrical propulsion they are having on board. Now, but what makes this mission stand out isn't just the satellite, it's what SpaceX is doing with the Falcon 9's upper stage after it drops off the payload. A deorbit burn is when the rocket's upper stage, the upper part that carries the satellite into space, fires its engine after dropping off the payload to make sure it falls back into Earth's atmosphere and burns up or crashes safely, usually in the ocean. Now, this is super important for keeping space clean and avoid space junk piling up in the orbit, which is a growing problem. Now, what makes the MTG-S1 special is the orbit it's dealing with. A geostationary transfer orbit is already, I said, that pretty eccentric, meaning it's going to be a big difference between its low point and high point, that is between the perigee and the apogee. Now for this mission, the apogee, the farthest point from Earth, is expected to be nearly triple the apogee of another SpaceX mission, which this booster, the first stage, which just got safely landed on its 9th flight, supported the SXM-10 mission, which reached about 22,000 kilometers. So as today it will be triple, so we are talking an apogee potentially around 60,000 to 66,000 kilometers or more. That's insanely high. It's like sending the upper stage way out into deep space and then asking it to come back home in a controlled way. Doing a deorbit burn from such a high apogee is a big deal because it's technically tricky. The farther you are out, the more energy it takes to change the orbit, enough to dip back into Earth's atmosphere. Plus, you got to time it just right, usually at a apogee where the rocket is moving the most slowest, to make the burn as efficient as possible. If SpaceX pull this off, it will be the first or at least a major leap forward, showing that they can handle these extreme orbits like nobody else. Now, to give you some context, let's talk about the previous XS, excuse me, this is hard to pronounce, SXM. It is like SXM 10 mission, which SpaceX launched on June 7, 2025 for Sirius XM. That mission sent a satellite into a geostationary orbit just like of today, with an apogee of around 22,000 kilometers, and Falcon 9 upper stage did a deorbit burn from that orbit. At that time, that was a big achievement, deorbiting from a geostationary orbit. That high showed that SpaceX could responsibly dispose of their rocket stages even after tough missions. The SXM-10 satellite weighed about 6,400 kilograms, which is a lot heavier than MTG-S1 MTG-S1's 3,800 kilograms. That is the payload for today. Now here it gets more interesting. Because SXM-10 was heavier, Falcon 9 used more of its fuel to get into the orbit, leaving less for fancy maneuvers like a deorbit burn. But for MTGS-S1, the lighter payload means the Falcon 9 has extra fuel to play with, which is a key for tackling the massive apogee, potentially the 3 times higher than the SXM-10 mission. The MTG-S1 mission is pushing the envelope way farther, testing the limits of what Falcon 9's upper stage can do in terms of orbit, altitude, and mission complexity. It's like SXM-10 was a tough hike, and the MTGS-S1 is like climbing the Mount Everest. Now, some more things to discuss. Today, it's a long time for the rocket launch, as because this mission could last around 20 hours. Now, here's why. After Falcon 9's second stage drops off the MTG-S1 satellite, which happens about 35 minutes after launch, approximately. It's 35 minutes and 11 seconds. So let's just consider it 35 minutes. The upper stage stays in the super eccentric geostationary transfer orbit. Now, to do the deorbit burn, which we discussed earlier, it likely needs to coast all the way out to its apogee, where it will be the closest to Earth, which could be approximately 60,000 kilometers or more away. The time it takes to travel from perigee to apogee depends on the orbit size. For a geostationary orbit with 22,000 kilometers of apogee, like the previous SXM-10, I pronounced it right this time. The orbital period time for one full loop is about 10 to 12 hours. Now, if MTG-S1's apogee is triple of that, the orbital period could be close to 20 hours or more. The upper stage might need to wait until it reaches apogee to fire its engine for the deorbit burn, because that's where it's moving the slowest, making it easier to change our orbit efficiently. So the rocket's just hanging out in space, coasting for hours, keeping its system running, and then firing up the engine again to come back to Earth. This long duration is a big test for Falcon 9's upper stage today. It's going to keep its power, communication, and thermal system working perfectly for nearly a full day in harsh environment of space. That's quite not trivial. It's like keeping your car running overnight in the desert without overheating or keeping out of battery. We will be having the MVAC engine ignition to be happening at T plus 26 minutes. So we are 7 minutes near about to go. So a little bit more. Let me give you the insight. The MTG-S1 or the Sentinel-4A payload at 3,800 kilograms is comfortably within the Falcon 9's capabilities, as I mentioned before. The Falcon 9 Block 5 can haul up to 8,300 kilograms to geostationary orbit with a reusable booster, or even more if they don't plan to recover the booster, if they will be expending a booster. Since MTG-S1 is on the lighter side, the rocket's second stage will have plenty of fuel left after dropping the satellite into orbit. That's great news because it means there's enough propellant to pull off that complex deorbit burn from super high apogee. The Falcon 9's second stage uses a Merlin 1D Merlin 1D vacuum engine, which we know, which is designed for in-space maneuvers and can restart multiple times, and that will be happening 3 times in today's flight. Already one time it happened. More 2 times it will be happening. More one time we will be witnessing it during the stream, and one finally during its deorbit burn. Now the deorbit burn is, as I mentioned, it's a complex thing. They are targeting SpaceX today as the fuel usable like to keep the fuel usable over a 20-hour mission isn't easy. That brings us to the next big challenge, and here's where things get dicey. That is the propellant boil off. Now let me explain it in easy terms. The Falcon 9's second stage uses cryogenic propellant, the liquid oxygen, that is a LOX, also known as LOX in short, and rocket grade kerosene, also known as RP1 in short, which are kept at super cold temperatures to stay liquid. In space, no atmosphere to insulate the rocket, heats that makes the heat from the sun or even the rocket's own system to cause these propellants to warm up and start evaporating or boiling off. Over a 20-hour mission, that's a real problem. If too much of fuel boils off, there might not be enough left to do the deorbit burn properly. And SpaceX has been working on this issue for years. They added insulation to the propellant lines and tanks for improved thermal controls to keep things cool during long coast missions like, as I discussed previously, SXM-10 and others like the Viasat 3 America's launch by Falcon Heavy have given SpaceX enough experience with extended course phases. But MTG-S1's 20-hour long duration and extreme orbit push the limits of what they have done before. It's like trying to keep uh, your ice cream frozen in a hot car for whole day, and you got to be really clever about it. Now, if SpaceX can manage this boil off and still have enough fuel for the deorbit burn, it will be a huge win for them. Now we are getting close to the next major milestone in today's flight, that is the MVAC ignition for the second time. That will be happening at approximately T plus 26 minutes and 54 seconds. It's less than, no, not less than, it's getting 3 minutes or so from now. Now the upcoming MVAC ignition that will be the second stage MVAC ignition, that is SES2 for the second time. That will be happening in today's flight. That burn will last around 1 minute and 6 seconds to be precise, boosting the payload to its target orbit. Approximately 2 minutes to go. If you are still hanging with us, please, if you felt that we somewhat added value to your viewing experience, providing a little bit of more insights for today's mission, please consider liking this stream, which helps this stream to reach out to a broader audience and let us to connect with more amazing space enthusiasts just like you joining us right now. I would be super grateful for your kind support. And we got the visuals out there for the second stage. I hope they will be showing the second stage MVAC ignition for the second time in today's flight. We are just about 30 seconds approximately or so for the next call out. What this ice kind of things are forming. I hope you guys noticed in previous telemetry there was a huge fluctuation in the altitude and speed all of a sudden. I don't know whether it was planned or not. Whenever I see these ice things on the second stage, it makes me scared. And there we go. We got the visual confirmation. Oh, there we go. Got the call out as well. It's the second time the second stage MVAC engine reignited for in today's flight. This is the second time, and the last time I guess it will be happening in during its deorbit burn. This burn will last around 1 minute and 6 seconds, approximately T plus 28 minutes. We should be having the call out for MVAC shutdown, that is the SECO 2. Turning off the MVAC engine on the second stage for the second time.
It's expected to send hourly data over Europe on aerosols, which are fine particles in the atmosphere, as well as on the concentrations of nitrogen dioxide, or NO2.
And back shutdown.
And back shutdown.
So it is, I hope you got the call out to be heard. And we got a call out that nominal orbit insertion as well. So that's a good thing and healthy call outs. And what I was saying that to the MVAC engine, second engine on the second stage, excuse me, I'm a little bit getting confused. The second stage MVAC engine happened a little bit from its planned 1 minute and 6 minutes of burn. It lasted a little bit more than the planned one. I don't know for what reason, but as I was mentioning that previously, I did saw a huge fluctuation in the speed and the altitude of the second stage during the course phase. Now, this course phase, we are again about in a 7 minutes of course phase before payload deployment. You can say today it's the second course phase. Today's SpaceX Falcon 9 launch is for EUMETSAT, the operator for the MTG-S1 mission. And this mission is poised to be a groundbreaking achievement, primarily due to its record-breaking deorbit burn from a highly eccentric orbit with an apogee potentially exceeding 60,000 kilometers, nearly triple that of SXM-10 mission, which was reaching the apogee of 22,000 kilometers in that mission. An approximately 20-hour mission duration driven by the need to course to apogee for the deorbit burn test Falcon 9's upper stage endurance and SpaceX's ability to manage propellant boil off. With the payload mass of 3,800 kilograms for today's MTG-S1 satellite, the Falcon 9 has ample of propellant to be in reserve, but the extended mission duration introduced significant challenges in thermal and propellant management. If successful, this mission will not only deliver a critical weather and air quality satellite to geostationary orbit, but also it will set a new standard for complex orbital maneuvers and, responsible space debris mitigation, reinforcing SpaceX's leadership in global launch industry. Now, the payload deployment will happen approximately T plus 35 minutes and 11 seconds, which is you can say 4 minutes, 3 minutes right now, you can say from now on, and the telemetry showed up on the screen. Right now we are getting some awesome views of the payload on board the second stage. Once again, just a quick recap, we had a successful liftoff from Launch Complex 39A. We did go ahead a good stage separation, followed by the second stage ignition for the first time. Then we had a wonderful landing for the Falcon 9's first stage on Just Read the Instructions drone ship at the Atlantic waters. And following that, we had just prior to the landing of the Falcon 9's first stage, we had the SECO 1 today. Now, after that, we had a 19 minutes of course phase. Then we again had the second stage MVAC engines to ignite for the second time. And right now we are again in the second post phase for about 7 minutes, that is getting to be complete as we are getting close to T plus 35 minutes. At T plus 35 minutes and 11 seconds, the payload deployment will be happening. So we are just close to the payload deployment, so I hang around to get those amazing visuals. And just quickly, we are getting close to the payload deployment. Just to quickly remind you guys that during both the second stage engine cutoff, we did got the call out for nominal orbit. So absolutely no issues. Now, in just 11 seconds from now, we will be hearing the call out for payload deployment. So let's listen in.
MTG-S1 payload deploy confirmed.
And there we go. And awesome views. This really fascinates me so much. With from such rapid speed right now, we are seeing this satellite to get deployed with such a slow speed, but it's not slow yet. It's still on like high speed. These callouts we were waiting for is successful payload deployment, and we didn't got the call out for nominal orbit insertion for the payload, but rest assured that it occurred as expected. Today's launch marks SpaceX's 510th successful mission, with landing marking their 470th success. So with that, we will wrap up our coverage for now. But before that, finally, and most importantly, we want to thank you for tuning in to our live launch coverage, wherever you are watching from. Really can't do this broadcast without your support. We are grateful for your continued encouragement for everything what we do here at AstroYonder. Don't forget to tune in for the record-setting booster flight in the upcoming Starlink mission. That is the Starlink Group 10-25, I guess. The stream is already posted on our channel and it's waiting for your visit. And also be sure to check out our social media handle on X for latest happenings in space industry and updates on upcoming launches. Link got posted in the chat section. And would like to welcome Jim M just before we are wrapping up our stream. Thanks, Jim, for being there with us until now. I know it was a little bit longer than the Starlink missions, but many thanks that you showed up your patience. I hope you all enjoyed the stream. We appreciate everyone joining us for today's launch. Wishing you a nice week ahead. Once again, thanks for watching. This is AstroYonder Live and me, Dipto, signing off for now, and we will see you next time.